Okay, so today we're going to start section 1 and section 4 of chapter 1. And this section 4 is all about quadratics. In this lesson, we are going to learn 4 different ways of solving a quadratic equation. Today we're going to cover 2 of them. We're going to cover solving quadratics using factoring and using the square root method. Tomorrow we're going to learn the quadratic formula. And then on Monday, we will learn how to solve the quadratic by completing the square. So those will be the 4 methods. You do have a quiz on Monday just on what we're covering today. And then on Thursday, you'll have a test. So here we go. So a quadratic equation is defined as the following. ax squared plus bx plus c, and it's going to be set equal to 0. Where the letters that are in front of here, the a, b, and the c, these are just real numbers. So, for example, I could have 2x squared plus 3x plus 4 equals 0. This would be an example of a quadratic equation where the numbers in front of x squared, that is a, the number in front of x is your b, and then the constant is your c value. The only thing that can't be a 0 is the a value. You need an x squared term in order for it to be factorable or to be quadratic. Now, prior to this, back in chapter, the review chapter, when we covered R4, we factored trinomials. So this is what we're going to do today, but we're going to take it one step further. And after we factor it, we're going to set it equal to 0 and solve for x. So when you read the instructions for the homework, they're going to tell you to use the 0 factor property. And if you happen to see this on a standardized test, just be familiar with it. What they want you to do is factor it and then set the factors equal to 0.
Wait, but for that, then it's the a couldn't be 0.
Right, so this is a different a and b. They're just telling you that if a and b are complex numbers, then you should know that anytime you're going to try to multiply a and b together to set it equal to 0, then either a is going to be a 0 or b is going to be a 0. So this a is different than the one in the standard form of the quadratic. This was just using 2 different variables. All right, so first thing we're going to cover is the square root, or the square root method, or the square root property. So back when we did geometry, and I don't know if you guys remember Pythagorean theorem or not, but we were really using the square root property or solving things using square root. So remember the Pythagorean theorem was a squared plus b squared equals c squared. And you use this formula to find a missing side length of a right triangle. So let's say we got our thing down to c squared equals 25. In order to find the side length, which was just going to be c, remember you square rooted both sides, and then you would find the side length to be 5. Now, when we did this in geometry, we never considered the negative square root because we never wanted a negative side length. But in Algebra 2, when we use the square root method, we are going to list our answers as both plus and minus. So this plus minus sign is just a short way, so you don't have to write c equals 5 and c equals negative 5. You could just put c equals plus and minus or positive and negative 5. So that's what that plus minus sign represents. Now, when we're solving these quadratic equations, what we're really doing is finding where our graph hits the x-axis. So the x's that we're finding is the x-intercept. So when we solve these, what we're finding is where our graph touches the x-axis or our x-intercepts. So for example, if you recall from Algebra 1, the graph of the quadratic equation takes on a U shape or an upside down U. This graph is called the graph of a parabola. Now, when we solve these, we can either get two solutions because our graph could come along here and touch the x-axis twice. We could get one solution, meaning our graph could be sitting right here on the x-axis. In the case where I drew this one up here, this would be no solutions, or it would hit it no times. And then we're also going to get imaginary roots, since we learned how to solve the complex numbers yesterday. So we can either get no solution, two solutions, one solutions, and we're also going to get imaginary. So these are going to be the type of solutions we're going to get. Now you don't have to identify what they are, but just realize that when you're solving these, you might get one answer, you might get two, you might not get any, or they might be imaginary and they're going to have some eyes in there. Let's try solving by factoring first. Now, on the test, on the quiz, it's either going to be factoring or square root. However, on the test, after we learn the quadratic formula and the completing the square, I will give you specific instructions on what method I want you to demonstrate. Now, technically, every quadratic equation can be solved using the quadratic formula or completing the square. Not all quadratics can be solved by factoring, because some of the trinomials may not be able to be factored. When that occurs, then you're going to resort to those other two methods. However, on the test, you need to read the directions, because I'm going to make you demonstrate that you understand how to complete the square, or that you understand how to use the quadratic formula. So I'm going to give you a specific method that you have to use. But for today and for the quiz, it's only going to be using factoring and square root method. So notice this one. You can look at it and say, oh, I might be tempted. I could do the square root method. But again, instructions say to factor it. So step number one, when we're solving by factoring, I need to set my equation equal to 0. So I need to move the 1 to the other side by subtracting it. And now I have an equation that I can factor. And this is actually the difference of two perfect squares. And this will factor into x plus 1 and x minus 1. Now, this is what we already did back in the review chapter in section R4. What's new today is we take each factor and set it equal to 0. So I take x plus 1, set it equal to 0, x minus 1, set it equal to 0, and I'm going to solve for x on each one. So subtract 1, x equals -1, add 1 on this one, and x equals +1. This would be the solution for that quadratic equation. And again, these solutions are our x-intercepts. Now, when we get into the graphing portion, these intercepts will help us give us some points to create our U-shape. But for now, all we're doing is figuring out what x equals. Let's try the next one. Now, notice the equation is already set equal to 0. It's not a trinomial. It's not the difference of two squares. However, I can still factor this thing. I can factor out a greatest common factor. So I'm going to divide both by x, and then I'm left with 3x plus 1. And I've just factored that quadratic equation. Now, if it said factor, we would be done. However, we are solving in this lesson, and I'm going to set each factor equal to 0. Now, this x over here is one of the factors. So you set that equal to 0, and that's one of your answers. And then I take the 3x plus 1 and set it equal to 0. This one I have to work for. I subtract the 1 and then divide by 3. So my two solutions are x equals 0 and x equals -1/3. These would be my x-intercepts for this quadratic equation. Again, the instructions are still to factor. Don't be tempted to just square root both sides. I need to set it equal to 0. So subtract x. X squared minus x equals 0. Again, it's not a trinomial. It's not the difference of two squares, but there is a greatest common factor. And that GCF is going to be x. So divide both terms by x. And I'm left with x times x minus 1. Again, we're going to take each of the factors, set them equal to 0, and solve for x. So my first factor is just x equals 0. My second factor, I would do x minus 1 equals 0. Add the 1, and x equals +1. And those would be my two factors and also my two x-intercepts. Pretty good? All right, let's try number 4. Now we finally hit a trinomial. All right, so factors of -8 that when I add them, or in this case going to subtract them, give me +2. Yes?
4 and 2.
Okay, so it's -4 and +2. Good?
No.
No, +4. Sorry, +4 and -2. I was looking at the answer. And then it switches. All right, so +4, -2. Now, my advice to you is foil this real quick. Do the outer and the inner and make sure that it went right. Because if you would have put what I said, -4 and +2, you would have gotten it wrong. Because it doesn't give you the +2 in the middle. It does give you the -8. So I highly suggest that you quick do a foil or at least do outer and inner to make sure that you do get that middle term correct. Okay, now we take each one, x plus 4, set it equal to 0, x minus 2, set it equal to 0. Solve each one, and here we go, x equals 2, and x equals -4. All right, next one. We do have an A term that is not a 1. Now, you can either do guess and test here, or you could do factor by grouping. I'll show you both. This one's probably simple enough where you could guess and test. Because for the factors of 2, there's only 2 times 1, so I could set that up. And then for 15, it's either going to be 1 and 15 or 3 and 5. And then you would just foil it to figure out which one works. So if I'm going to try 5 and 3. Again, to get a -15, my signs have to be different. So if I put a plus sign here and a minus sign here, this one's going to work. But let's go ahead and do the whole factor by grouping. Because I know not everybody is good at this guess and test. Because sometimes when the numbers are large, you got to do a bunch of guess and test. So let's go ahead and do the factor by grouping over here to the side, and then I'll finish solving it. Okay, so for here, I'm going to multiply 2 times -15. So I'm looking for the factors of -30 that when I add them, I get the middle term, which is -1. So I'd go through 1 and 30, 2 and 15, 3 and 10, 5 and 6. Again, it's a negative. The sign in the middle goes on my bigger factor. And here we go. Whenever that middle term is a 1, that should be a clue that your factors need to be right next to each other. So now, if I go to factor this thing, and I know I'm missing a square here, again, you're going to rewrite the first term, put in the two factors you just found, so plus 5x minus 6x, and then rewrite the last term. Now you make your groups. Now, it didn't matter how I put that in there. I could have put the -6 first. I still would get the same answer. So let me go ahead now and factor out a greatest common factor. So from my first group, it's going to be an x. And then after I divide out the x, I get 2x plus 5. Out of my second group over here, my greatest common factor is going to be -3. And then I'm left with 2x plus 5. Again, your goal is to make sure that these two things look the same. Once they look the same, that's now your new GCF. Write it once, and then group these two together. And notice it was the same factors I got when I guessed and tested. Now, I'm not done here because my instructions did not say just factor, they said solve. So now I need to set each of the factors equal to 0. So 2x plus 5 equals 0. And then x minus 3 equal to 0. Subtract the 5. 2x equals -5. Divide by 2. And my first solution is -5/2. And over here, add the 3. And x equals +3. Now, I'm okay with you leaving it improper. If you were graphing, I would suggest you turn the -5/2 into a decimal or a mixed number, but you can just leave it improper. The next one, I know I wrote on top of it, so let me rewrite it down here. Okay, now, to make things easier, I highly recommend when you rearrange this and set it equal to 0, to try to keep your x squared term positive. So instead of moving the 10 over and adding it, I'm going to add the 6x squared to the other side. And 7x equals 6x squared minus 10. Then move the 7. You could have factored it with a negative. It just makes it a little bit easier if that leading coefficient, the number in front of x squared, is positive. Okay, now that I've moved everything to the left and now it's set equal to 0, actually I moved it to the right, but then I shifted it back over. Now I'm looking for, if I factor by grouping, let me go ahead and do that on here, I would multiply beginning and end. I'm looking for the factors of -60 that when I add those factors, and in this case I'll be subtracting them, gives me -7. -12 and +5. Good. So again, if I'm factoring by grouping, rewrite the first term, replace these with what you just got. So -12x plus 5x, and then rewrite the last term. So now we make our groups. First group, and then the last group here. Greatest common factor of my first group is going to be 6x, and then I'm left with x minus 2. GCF of my second group is going to be +5. After I divide, I get x minus 2. Again, remember, your goal is to make these two the same. So that is now my GCF. Write it once, and then write these two guys that you had divided out to begin with. Now, again, we're not done. All we've done so far is factor. Now we set the factors equal to 0. So x minus 2 equals 0. 6x plus 5 equals 0. Add the 2. X equals 2. Subtract the 5. 6x minus 5 or equals -5. Divide by 6, and x equals -5/6. So that would be your two solutions, or where your graph hits the x-axis. So that is the factoring method. So sometimes you're just factoring out a GCF, sometimes it'll be a trinomial, sometimes it'll be the difference of two squares. Next, we're going to see the square root method. So again, when I'm using the square root method, I'm going to square root both sides of my equation to get just what x equals. So remember, when you square root a square, it causes it to cancel. So now I'm left with x is equal to plus and minus the square root of 17. Now, if that 17 could be simplified, I would leave my answer in simplest radical form. I cannot break 17 down, so I'm done. The next one, again, I'm using the square root method for here. When I square root both sides, this is what we learned yesterday. I'm square rooting a negative number. So again, this will become plus and minus negative 25. I need to break it down, make it positive 25 and negative 1. Square root the 25 to a 5, square root the negative 1 to an I, and it has the plus minus sign. So again, our two solutions here are either x equals 5i or x equals negative 5i. So here's our imaginary solutions because they have the letter I in there. Yes?
Can we just write x equals plus and minus 5?
Absolutely. Now, keep in mind when you're taking the SAT or the PSAT, sometimes what they'll do is they'll pull them apart. And then other multiple choice questions will leave it with the plus minus sign. So just be aware that both, you can see both ways when you take that test. All right, next one. Still using square root method. Now, normally what we would have to do when we see a binomial squared is write it 2 times and FOIL it. But again, I'm using the square root method, and this whole thing is being squared, so I can square root the entire thing. When I square root a square, it cancels it, and now just the x minus 4 falls out. And then I get plus and minus 12. Again, I need to simplify the square root of 12. There's some perfect squares hiding in there. I can break it down into 4 times 3. 4 is a perfect square, so 2 square root 3 still has the plus minus in front, and I got to drop down this left side because I'm not done yet. Because remember, we're trying to figure out what x equals. X isn't by itself yet. I need to move that 4 over. So I will add 4, and x is equal to 4 plus or minus 2 square root 3. Now, notice I did not add the 4 to the 2 because the 4 did not have the square root 3. Remember, when you add radicals, treat them like variables or like adding like terms. So that would be my simplified answer here. And again, you could pull it apart. You could say the answer is x equals 4 plus 2 square root 3, or x equals 4 minus 2 square root 3. Again, I'm okay with you leaving it with the plus minus sign. Next one's pretty basic. It's just a perfect square. Square root both sides. And again, don't forget, it's plus minus. 25 is a perfect square. Let's try another one. 48. X squared equals 48. Again, square root both sides. X is equal to?
These IDs are working.
Down, there's some perfect squares hiding in here. I can break 48 into 16 times 3. Then I can square root the 16. And again, don't forget it's plus minus. So plus minus 4 square root of 3. So again, always leave your answers in simplest radical form. So if there's perfect squares in there, we got to break them out. Try number 6. Again, we're going to square root both sides. This becomes plus and minus the square root of negative 100. I can factor the negative 100 into 100 times negative 1. And again, square root of 100 is 10. Square root of negative 1 is I. Good so far? 2 more examples and we're done. Next one, same thing. All we need to do is square root both sides. This causes the square to cancel. The 4x plus 1 drops out. This becomes plus and minus square root of 20. Inside that 20, I can factor it into 4 times 5. Drop down this side. 4x plus 1. The square root of 4 is 2. 5 can't be broken down. Again, your goal is to find the value of x. So I need to first subtract the 1. 4x equals negative 1 plus or minus 2 square root 5. Again, I don't subtract that 1 from the 2. It doesn't have a radical 5. And then now, last step, divide by 4. So negative 1 plus or minus 2 square root 5 over 4. Now, you can leave it like this. If you try to simplify it, that 4 needs to go into both. So you could write your answer as negative 1/4 plus or minus 1/2 square root 5. I think you should just leave it like this. You're less likely to make a mistake. So just remember this 4 needs to simplify both. If you want to pull it apart, you can, but I would leave it. Last example, same process. Find the square root of both sides. So square root. This causes this to cancel. You're left with negative 2x plus 5 equals plus and minus negative square root of 8, or 8 square root of negative 8. I need to break down the negative 8 to 8 and negative 1. I can still break down the 8 into 4 times 2. And now I'm going to pull out a 2, and I leave the radical 2 there. Now let's bring this all the way down. I should have been really rewriting it the whole time. And now subtract the 5, and this is plus minus. Negative 2x is equal to negative 5 plus or minus 2i radical 2, divide by negative 2, and x is equal to negative 5 plus or minus 2i square root 2 over negative 2. Now you can leave it like that. If you don't like looking at a negative sign in the bottom, you could divide everything by negative 2, or by the negative, and make this positive 5. when you divide this, the plus minus, it just stays plus minus. And then you can make the bottom positive too. But honestly, I would just leave it like that. Just so if you're not sure about what exactly you're simplifying. Homework for this lesson is numbers 13 through 29 odd. Again, tomorrow I will be posting a review for the quiz. It'll be more practice of this same homework. And then I'm also going to teach tomorrow solving using the quadratic formula. It's pretty basic. All you do is plug in A, B, and C and follow order of operations. That's it. Any questions? All right.